Hi, this is RT. This video will more clarify a concept of connected bodies and how to use Lami's theorem and how to calculate various angles. So this is a question of non-concurrent coplanar forces. You see here in this diagram, arrangement has made like this. I am drawing the sketch again. Okay. So you first of all, I just read out the question. What is the question? The question is that a rope AB, a rope A and B as shown in figure. So this is the rope A, C, D, B as shown in figure is 4.5 meter long and is connected at 2 points A and B at the same level 4 meter apart. Okay, so the distance between A and B is 4 meter. Okay, so this distance is 4 meter apart. A load of 1500 Newton is suspended from a point C like this on the rope at 1.5 meter from A. At 1.5 meter from A. What load connected at point D on the rope 1 meter from V? This is the unknown. From B 1 meter. So this distance is 1 meter. The total length of rope is 4.5 meter. 1 meter from B is necessary to keep the position CD in the level, as this angle is alpha and this angle is beta we assumed to find the same arrangement of the system, to keep the system in same shape like that. So this is the problem. So here this is two bodies are connected like this is first system and this is second system. I can just consider two systems because joint C and joint D, these are the points A, B, C, D, E, F. We assumed like so actual the diagram is, you can see like this. This is the rope, this is the rope A, B, rope AB and connected on a wall which is 4 meter apart, and C, D are the points where loads of 1500 and W is to be found, and these are the lengths 1.5, 2 and again 1. So this data is given to us. So we have to find out the various unknown forces. So first of all, I think I should consider joint C. So when I consider joint C, I see here like this. Let us assume this is T1, T2 and this 1500. I see here there is this is unknown force, this is unknown force, and angle is also, oh, it's not visible. I just draw this diagram. So this is let us T1, T2 and 1500 Newton forces here. So you see here many unknowns are here. T1 is unknown, T2 is also unknown force, angle is also known to us. So first of all our calculation will work for angle. So let us assume the angle, this angle is alpha and this angle is beta. So I can find out the angle using this geometry like this. If this total length is 4 meter apart, this 4 meter, so the total x, let us assume x1 and x2. This is x1 and this is x2. This is x2, correct? This is x2. So this is x1, this is x2. So x1 and x2, let us assume this is ordinate y. We assume this as a y, and x1 plus x2, how much? X1 plus x2 is equal to 4. This is 4 minus 2 is equal to 2 meter. Clear? This distance is 4 and this is 2 meter, so this is 2 meter, x1 plus x2, and this is y. Let us find this angle alpha and this angle is beta. To find, we have to calculate this is 1.5, this is 1 given. Let us assume, तो सबसे पहले मैंने using Pythagoras I can write here x1 square plus y square is equal to 1.5 square. This is 1.5 square, and from here I can write y is equal to 1.5 square minus x1 square, and from second side I can write here x2 square plus y square is equal to 1 square. So again y is equal to 1 square minus x2 square, and we know that x1 is equal to 2 minus x2. I can write here x1 is equal to 2 minus x2. So from here y is equal to 1.5 square. It's not visible completely. I just write here and just write here calculation. So for this I write here x1, this is x1 square plus y square is equal to 1.5 square. That was the equation number 1. So from here I can write here like this y square, okay, y square here also, y square is equal to 1.5 square minus x1 square, and x1 is equal to 1.5 square minus x1 is equal to 2 minus x2 in the square. Okay, so from here I can write 1.5 square. So open this, so 4 minus x2 square, this is the plus, a square plus b square minus 2ab, and a square plus b square minus 2 into 2 4 x2, this is the equation. So this is equal to y2 square, okay, y square. So from this equation is, let us assume this equation is 1, this equation is 2. So from equation 1 and 2 I can write here, from equation 1 and 2 I can write here y1 square minus x2 square is equal to 1.5 square minus 4 minus x2 square, okay, and plus 4x2, correct? So again I show you, I write here. So this is the equation. From here I can calculate the value of x1 and x2. Okay, let us exchange this. So here is, okay, so just exchange like I write here. So I write 1 x2 we can write as a final equation like this, 1.5 square, 1.5 square, okay, then we change here minus 4. I just simplify the equation in that way, like this, like 2.25 it's not visible here. I just write here like this. Now I think I should delete this, it's not required. So here I write 1.5 square is 2.25 and minus 4 minus x2 square plus 4x2 and minus 1 plus, and this is also plus x2 square is equal to 0. From this equation we can find the value of x2. Okay, so how? So after solving this equation, like x2 square and this is plus x2 square, this is minus and this is plus, x2 square cancel out. So here the value is this, this, this and this. So I use cal C. So 2.25 minus 4 and this minus 1 is equal to 2.275, and so here 4x2 is equal to 2.275. so 2.275 divided by directly 4 is equal to x2 is equal to 0.687. so this is the value of x2, and now the value of x1 from this equation number this relation. So x1 is equal to, I write here how much, 2, this answer is equal to 1.3125 meter whatever. So this is the value of x1. That is a simple calculation, and now you can find out the various angles using x1 x2. So I should delete this. So now x1 and x2, x1 is equal to 1.3125 and x2 is equal to 0.687. so using this, alpha is equal to, we can find cos alpha. So this is the cos alpha, so is equal to base over hypotenuse. So x1 is 1.3125 over hypotenuse. So from here alpha is equal to 1.3 divided by directly 1.5 equal to, and shift cos inverse, answer is equal to 28.95 degree is the value of alpha, and similarly the value of beta is equal to, I write here cos inverse base over hypotenuse, so 0.687 divided by, so this is 1. So how much? Beta is equal to 0.687. okay, shift cos inverse, answer is equal to 46.5. so I write here cos beta is equal to 46.60 degree. So once we know the angle, we can easily apply Lami's theorem in any case. So as I already told you, I think I should delete this equation. So now alpha and beta is known to us. So consider joint C. Joint C. So this is the force, this is the force, this is the force, 50, 100, and this is, let us assume T2, and this is T1. So okay, this angle, if this angle is alpha, this will also be alpha. Okay, so Lami's theorem, we calculate these angles, this angle and this angle. So this angle is alpha plus 90, so 28.95 plus 90 will be equal to this angle, and this angle will be how much? 180 minus alpha. 180 minus alpha will be this angle, and this is the 90. So I directly write here T1 over this angle of with sine. So T1 over sine 90 is equal to T2 over how much? 20. This I write here sine 28.95 plus 90, correct? And that will be equal to 1500 divided by sine 180 minus alpha. So from here we can get T1 and T2. T1 and T2. So T1 is 1500 divided by sine 180 minus 28.95, that is close, and into sine 90. Okay, so this angle, this is value of T1 is 3098.87 is the value in Newton, and the value of T2 similarly into sine 90. Okay, so into, for the value of T2, sine into 28.95 plus 90, bracket close. So this is the value of T2, 1.1 Newton. So this is the value of T1. Okay, so similarly we can also make our calculation for joint C. For joint C, applying Lami's, and you have to calculate these values of T3 and W. So I write here the answer 3943.4 Newton. Okay, you try to solve as a practice, and W will be 2863.6 Newton. I hope you get clear now this fundamental. So you can solve you can apply Lami's theorem by assuming all the forces, like at joint D. I just show you the forces like this at joint D. This will be the one, this will be the one, and this will be the one, because these two forces are the forces you don't know the sense, direction, anything. So unknown force, just line of action of force you know, so you can calculate angle and the sense of force. Like, so here in this case also we assume this like this, and now analyze these forces. W here it is known to you. Now the force T2 will act, this is important. From this T2, for this part you have calculated this T2, so same T2 will also behave like from here. So this T2 and this force is like T3 you assume, and this is W. So here T2 is known, and T3 and W you have to find. So simply you can find using Lami's theorem like we saw here in this case. So I think this is clear to you now. So now one more problem I just discuss here. Like, this is the problem. In this case, for this joint neither angle is given nor force. So we have to calculate both angle and forces. So simple geometry and again Lami's theorem we can use for this case. So this is the problem. I just read out the problem. Problem is this. So a wire rope is fixed at 2 points A and D. So this is the wire rope already fixed. Okay, as shown in figure. Weights 20 kN and 30 kN are attached to it at B and C. These are the weights respectively. The weights rest with portions AB and BC inclined at 30 and 50 degree from vertical as shown in figure. Okay. Find the tension in the segments AB, BC, CD of wire. Determine the inclination of segment CD of wire. Definitely, if you only you can find out the tension after once you have calculated the angle of inclination, okay, of rope CD. So a very simple approach you can use. So in this adjoint B, you may apply directly Lami's theorem. ठीक है, so apply Lami's so here, okay, so directly apply, you can apply. So you know this angle and this is horizontal, this is vertical line, and you also know this angle and this load, this is 50 and this is 30. Okay, so you can apply Lami's theorem for these. Okay, so you just use this angle. So if this is 40, this is 90 and this is 30, so 90, 30, 40, this is 160, so 90 and 70, 160, and this is 50, these two forces, and this angle is again how much, 90 plus, and this is 30, so this is 60, so 150. So apply Lami. So let us assume this is T1, this is T2. So simply we can assume Lami's theorem. Okay, so applying Lami's will give you T1 over sine of this angle between these two forces. T1 over sine 50 is equal to T2 over sine angle between other two forces, sine 150 is equal to T3 over T3. So this is the T3 means the load is acted here is 20, so I should write here 20 divided by sine 160, so 160. So from here I can calculate T1 and T2. I write here T1 and T2. So what is the value of T1 is 44.80 Newton and the value of T2 is 29.2 kilonewton. All the forces are in kilonewton. Okay, so this will be kilonewton. Okay, so once you know the T1 and T2, then in this case we have to apply both Lami's theorem and equilibrium conditions. So this joint C can only be analyzed after applying equilibrium condition. So at joint C, we cannot apply Lami's theorem because unknown are more than 2, so we can only but angle, actually the angles we are not able to calculate the angles, so we can only apply equilibrium conditions. So okay, so apply equilibrium conditions at joint C. Apply equilibrium conditions. So equilibrium conditions, simply free body diagram at this joint can be seen like this and this. 30 kilonewton, and this is let us assume this is theta. So now this is T2 force. Now this already assumed T1, T2, so this will also be T2, and this is T3. So T3, T2, and W 30 kilonewton. So T2 over T2 over. So I just writing equilibrium condition. So summation Fx is equal to 0. So here T3 cos, if this angle is theta, so this angle is theta, and this is cos theta, this is sin theta. So I write here T3 sin theta, T3 sin theta will be equal to T2. This angle is known to us. How much this angle? If this angle is 50 degree, that will also be 50 degree, and this will be 90 minus 50 or 40 degree. I write here 40 degree. Okay. So T2 here, how much? Cos 40 degree will be the equation. So from here T3 sin theta is equal to T2 cos 40. T2 how much? 29.2 cos 40 will be equal to 22.36. Okay, Newton is a T3, and similarly writing equation for summation Fy. Summation Fy is equal to 0. I write here directly. So Fy is equal to 0. Here I can write T2 upward force is positive, we are taking here, and downward negative. In this case we took this force positive, and like a simple equation, so I did not mention the sign. So T2 and this component, vertical component, this is cos 50. Even I can write cos 50 degree, because this angle is 50, so this will be 50 cos 50, T2 cos 50 plus T3, how much? T3 theta, T3 cos theta, and minus 30 is equal to 0. This is the equation. So I write here clearly. So T2 cos 50 is already known. So this is 29.2. 29.2 is a T2. Okay, we have calculated, and T2 cos 50. T2 cos 50 is of 18, and this is minus 30. How much? 11.2. So this we can write T3 cos theta is equal to 11.23 kilonewton, if kilonewton is there. So from equation number 1 and this equation number 2, I can write here by dividing T3 sin theta, okay, and over T3 cos theta is equal to 22.36 divided by 11.23. So sin theta cos theta tan theta is equal to tan inverse I directly. So 22.36 divided by 11.23. Okay, and shift tan answer is equal to theta. I directly write here theta is equal to 63.33 degree, which is asked in the problem. So this was the solution, and from here you can also calculate the value of T3. So T3 now I just calculate here. So from T3 is equal to, now cos theta is equal to this, so 11.23 divided by answer is equal to T3 is equal to 25.04 something Newton or 2 Newton, kilonewton. is the answer. Okay, so this was the answer. 4 kilonewton was the answer. So this was the procedure to solve. One more problem I just give you to solve related to this topic. You can try as a practice. Okay, so this is a diagram you see here. The wire support connected at this location like this, and again like this and like this. Okay, so from orientation of this cable is 60 degree from vertical, and at this joint load is hanging of 20 kilonewton. At this joint load is hanging of 25 kilonewton, and the orientation is of this is 30 degree. So B, A, C. Okay, these are the points A, B, C, and this is D. So now question is that a wire is fixed at A and D as shown in figure. Weight 20 kilonewton and 25 kilonewton are supported at B and C respectively when equilibrium is reached. Okay, when equilibrium, so this is the equilibrium given. So this angle is theta assumed. Equilibrium is reached. So what is the equilibrium? Equilibrium means ये लोड्स लगने के बाद ये एक पर्टिकुलर कंडीशन लोकेशन में आ जाएगी जो फिक्स हो जाएगी. सो एंगल वहां पे फिक्स रहेंगे उस कंडीशन में. सो नाउ when equilibrium is reached, it is found that inclination of AB is 30 degree and that of CD is 60 degree to the vertical. Determine the tension in the segment AB, BC and CD of the rope, and also the inclination of BC to the vertical. So okay, so with the simple question, definitely it is asked the tension in this rope and this rope and this rope and inclination of this. Okay, so this is the homework for you, and if you are unable to solve the problem, you may write this in comment. I provide you the answer. Let us assume this force is T1. So T1 is equal to 38.97 kilonewton, and T2 is equal to 23.84 kilonewton is the answers. Okay, and angle theta, which is also asked, 23.84 kilonewton. Okay, so these are the unknowns. Simply you can find out. You apply. I think you already know you cannot solve this problem by applying the Lami's condition because angles are unknown. So angle must be there for applying Lami's. So you have to use equilibrium conditions at joint B, at joint C. Okay, so the conditions will only help you to find the various unknown forces. Okay, so you can plot the free body diagram at joint B and joint C, and this is sufficient data is given. So I hope you will be able to solve. If you are not able to solve, write in comments. I will guide you. So okay, so keep watching and subscribe this channel. We'll also bring some more good quality questions and practice question also. Okay, and thanks.